All right, so sample problem 14 tells us that it wants us to write balanced total and net ionic equations for the following reactions and use curved arrows to show how the proton transfer occurs. Now remember, a proton is just an H plus. It's a hydrogen with a plus charge. So that's what we're going to do here. In A part, I have hydrochloric acid, that's HCl, plus calcium hydroxide, CaOH2, AQ, right? Calcium has a 2 plus charge, hydroxide has a -1, so I got to have 2 of those. Yields. So now I'm going to trade partners, right? So the hydrogen is the positive, right, in that one, and the hydroxide is the negative in that one. So they're going to pair together, and anytime I have an H and an OH, right, remember they form H2O. Plus, now I've got the positive here and the negative there, right? So those two ions are going to pair together. I'm going to form calcium chloride. So plus CaCl2AQ. Now, how did I know that I needed 2 chlorines? That's probably a question you have, right? This has a 2 plus charge. Chlorine has a -1 charge. I got to have 2 of those -1 charges to cancel out the 1 2 plus charge on the calcium. Therefore, I got calcium chloride. How did I know this was AQ? If I check my solubility rules, right? Chlorides are soluble. They're all soluble, and there's a few exceptions, but calcium is not one of them. So calcium chloride is, in fact, soluble. It's going to break apart. It's and be soluble in water. So now the next step is to check to see if this thing's balanced, and I don't think it's going to be, but let's just see. No, it's not, right? Because immediately I've got 1 chlorine, 2 chlorine. So let's see, if I put a 2 there, does that fix things? Now I have 2 chlorines, 2 chlorines. I have 1, 2 hydrogens plus 2, that's 4 hydrogens. Oops, I don't have it over here, so I better put a 2 there, right? So if I put a 2 there, I now have 4 hydrogens on both sides. What about my oxygens? I've got 2 oxygens, and now I have 2 oxygens. All right, so everything's balanced out. Now I have to do my net ionic equation. That's the next step, right? So I've got to break apart things that break apart. Hydrochloric acid is a strong acid. It breaks apart. So I've got 2 protons, AQ, plus 2 chloride ions, AQ, plus a calcium with a 2 plus charge, right? It's aqueous, so it breaks apart. It's soluble. Plus 2 hydroxides, that's a negative, yields 2 waters. Water's water. It doesn't break apart, right? It's liquid water. Plus, I'm going to come down here, a calcium with a 2 plus charge, AQ, plus 2 chlorides, AQ. All right, so now I'm going to identify my spectator ions. Let's see, I've got my 2 chlorides, my 2 chlorides. I've got my calcium, and that's pretty much it. Right, so now I'm going to write my my net ionic equation. From that, I'm going to bring down everything that's not a spectator. So let's see, I've got 2H plus 2OH minuses yields water. 2 waters, right? All right, so let's see here now. What do I have? I've got to use my curved arrows to show that proton transfer. So let's see, this proton is going to go over here to this oxygen, right? And I'm going to have my 2 waters that are forming. So what about up here? I've got this proton's going to go over here with these guys, and they're going to do that, right? And then right here, I would show this one going over here to this oxygen. And that's how I would use my curved arrows. And you always draw the arrow towards the direction the proton is going, okay? So whichever the direction is where the hydrogen's going towards, which would be the oxygen in this case, you draw the arrow that way. And I'm going to leave B part for you guys to do, but I will give you this one hint, okay? Notice it says propanoic acid. Propanoic acid is a weak acid. It is not going to break apart in solution. Weak acids do not. They stay together. Potassium hydroxide will break apart. Propanoic acid will not break apart because it's a weak acid. Okay?